So we're going to start off by looking at transformations of functions, and in particular, the first ones that we look at are translations of functions, translation of functions. Translation, what is a translation? It's just a moving. It's literally just a moving left and right or up and down or a combination of those things. So I've got a few different things we're going to think about here, and we're going to think about how these graphs have changed. And then we're going to do a demonstration on Desmos as well. So suppose that f of x is equal to x squared. That means whatever your input is, you're squaring it. And it wants you to sketch y is equal to f of x. In other words, sketch y equals x squared. Now, we know that y equals x squared is just a quadratic graph. This graph that I've drawn here is y equals f of x. It's just a quadratic graph that I've got, okay? Then my next one that I want to draw, I'll give you a chance to just draw that one to start off with. Now, we're still talking about the same function, okay? In this first function, you put in x, and then you square that thing. This time, the function says we're not going to put x into the function. We're going to put x plus 2 into the function. So we're no longer going to be sketching x squared, but we're going to be sketching x plus 2 squared. Let me just say that one more time. The function notation says here, we're no longer putting the input value as x, we're putting the input value as x plus 2, which means it's not going to be x squared anymore. It means it's going to be x plus 2 squared.
Why is it squared?
Because the function is a squaring function. It's the same function as before. So instead of it being the input being squared, it is this input being squared. So on the graph is going to be y equals x plus 2 squared. Okay. Well, that's not a very clear axis. I should have done that a little bit better. If it is x plus 2 squared, it's going to be a quadratic graph. Where are the roots going to be? The roots are going to be a repeated root of x equals minus 2. So it's going to be over here now at minus 2, and it's going to look like this. Yes, I should probably do the y-intercept as well. What is the y-intercept? 4. Okay, I'm not going to bother putting it on the graph because I'm just concentrating on this thing. And then I'm going to think about this last one that we've got here. This last one, the input is the same. So the function is just an x squared. But you'll notice I've done something else to the function. I have added on 2 to the function. So I'm now going to be sketching y equals f of x plus 2. So it's going to be x squared plus 2. So what do you think this is going to look like if I sketch the graph, or if I sketch x squared plus 2? Pardon? It's going to move up 2 spaces, okay? So previously, it was crossing at 0. It's actually, everything is having 2 added onto it. So that means it's now going to be a quadratic that looks like this. And instead of it crossing at 0, it's now going to be crossing at 2. So this was our starting graph. This red one here is our starting graph. And the first question that I've asked us at the bottom is I've said, what do you notice about the relationship between the graphs y equals f of x and y equals f of x plus 2? What does it look like has happened to y equals f of x for it to become y equals f of x plus 2? It's gone 2 to the left, okay? It has shifted to left, which I'm going to be a little bit more sophisticated with the way I describe that. I am going to say that it is a translation of minus 2, 0. It's gone minus 2 to the left. And that's because of all of our knowledge about roots here. We know that the root became minus 2, so it shifted 2 to the left. Now, this one is also going to be a shift. What do you notice about the relationship between f of x and the one at the end? It's gone up 2. So this one has shifted 2 up, and it is a translation of 0, 2. So it's unfortunate that they both don't do exactly what we would have liked. If I had just said, oh, it's an x plus 2, it would have been nice if it moved 2 to the right because it would have just been exactly the same. But it's not. Okay? For the ones when it goes inside the brackets like this, it shifts it in the direction you might not have expected. And that's because of the roots that we were talking about there. We're going to do a bit of a demonstration with this on Desmos on the next page to see what is happening. Okay? Everyone got those drawn? So I'm going to do a demonstration in a second. But what I've got here, the same graphs that I was talking about, I've got the y equals x squared graph in black, and then I've got the y equals f of x graph, and then I've got f of x plus 2. And you can see that the orange graph, which is f of x plus 2, the black graph has shifted everywhere 2 spaces to the left. The x coordinates have all decreased by 2. So what has happened to the y coordinates when f of x is transformed to x plus 2? I actually don't think I was meaning to ask about the y coordinates. I was meaning to ask about the x coordinates. So what's happened to the x coordinates? The x coordinates have decreased by 2. So can you just make sure you've changed the question to x coordinates? They have decreased by 2. And then for this one down here, you can see how the graph, the black graph is f of x, and it's become f of x plus 2. Notice how these blue arrows are all 2 units long. Every single y coordinate has increased by 2. So what has happened to the y coordinates? They have increased by 2. And the thing I like to notice here is that the size of the blue arrows is the same everywhere. This blue arrow is the same as this blue arrow, which is the same as these ones, because every single x coordinate is decreasing by 2. It's a bit harder to see with the y ones, because some people think that the shift down here at the bottom is bigger, because it looks like a bigger gap at the bottom, and they think that this gap isn't very small, they think this gap is smaller. But if you look at my blue arrows, you will notice the blue arrows have all got a length of 2. They just look like they're closer together here, but they are still moving 2 units upwards. And so I'm going to do a bit of a demonstration for you on Desmos. So you will see here that I have put a cubic graph. I've just made up a cubic graph. I did x minus 3, x plus 2, x minus 1. So you can see that its roots are at minus 2, 1, and 3. And I have written that my f of x, I'm going to change it to f of x plus a. Now, if I make a become a positive number, what is going to happen to the graph? To the left. If a is a positive number, it goes to the left. So when I move a 1, do you see how the blue graph is starting to shift to the left? So I'm making a become a positive number, and it moves the graph to the left.
Why does it do that?
It does that because of what we just did on this page that we had here. When I did x plus 2 squared, the roots changed to minus 2, so it shifted to the left. So when I go back here, this is actually, when I change a to 4, I'm shifting all of these x coordinates 4 to the left. It kind of does the opposite of what you'd expect it to do. When you see f of x plus 4, you would go, oh, I think the blue graph is going to move 4 spaces to the right, but it doesn't. It's because the roots are moving in that other direction. And if a became a negative number, it moves to the right, because it kind of does the opposite of what you might expect it to do. So what I've written on the page for you here is that f of x plus a is a translation of f of x by minus a, 0. It does the opposite of what you might expect, or what it looks like. It's not really the opposite of what you expect, because it makes sense with what we've discussed with the roots, but it kind of plays with like the opposite idea. And then the next one we're going to explore is f of x plus a. So I'm going to go back to Desmos, and I'm going to change it from f of x plus a inside the brackets to f of x plus a outside the brackets. And when a is equal to 0, it's obviously just the same graph. This time, when I make a become a positive number, the blue graph is going to go up. And you'll see what's happening here. The blue graph is going upwards. Now, like I just said, people think that there is a bigger gap here than there is down here. But there isn't a bigger gap. If you went to all the x coordinates and you drew vertical lines, all of those vertical lines would be the same length as each other. The y coordinates are consistently moving up the same amount. What I mean by that is that gap there is the same the whole way down. It just doesn't look the same because of the way our eyes think that's really close together. But that's because it's actually being measured in that direction instead. And if I make a become a negative number, it is going to go down, okay? It's going to move down like this. So if it's outside the bracket, it moves up and down. If it's inside the bracket, it moves left and right. And that's what I've got written here. If you're adding something on to the function, to the graph afterwards, it is going to make it move up and down by that amount that we've got there, okay? And we're going to slowly build up lots of these different transformations so that we can think about how these graphs will change. So we're going to dive in now with some examples. The first thing it wants us to do is to sketch the graph of y equals 2 over x plus 1, ensuring you indicate any intercepts with the axes. Now, we don't know how to draw y equals 2 over x plus 1, but what we do know how to draw is y equals 2 over x. We know how to draw y equals 2 over x. So I'm going to say, to make this a bit easier, let f of x equal 2 over x, because we know how to draw 2 over x. Then y is equal to f of x plus 1. Okay? Because f of x is the thing we know how to draw already. We know how to draw a reciprocal graph. And we now have got that we're going to add 1 to it afterwards. And so this is a type of transformation. And this is going to be a translation of what? 0, 1. So I'm going to start off by drawing, and I'm going to draw this in a pale colour. I'm going to draw y equals f of x to begin with. I'm going to draw 2 over x. And 2 over x, I'm going to do it in this pale colour. We know that 2 over x looks like this. And we're going to take that graph and we're going to move it up 1 space. If I move it up 1 space, we have to be careful about some asymptotes. Do you remember what the asymptotes are?
The lines that
yeah?
almost...
Yeah, you're almost there with it.
Almost touch that.
They almost touch those axes. So at the moment, it's almost going to touch this line here. Well, if I'm moving it up 1 space, I'm going to want it to almost touch this line instead. And an asymptote, we draw with a dotted line like this. So it's now going to move like this. It's going to go up like that. And it's going to be, this grey line is going to move up 1 space so that it's like that.
So it's just like estimate of what 1 space up would be.
It's just an estimate of what 1 space up would be because we don't know what 1 space up would be. I can put it in Desmos, but it's not going to make a difference. I could have done 1 space here. I could have done one space up here. And I'm going to give the name of this asymptote. What is the name of this asymptote? Not x equals 1, y equals 1. That asymptote is y equals 1. And the graph that we have drawn here is y equals 2 over x plus 1. But it did ask for something else as well. It says indicate any intercepts with the axis. 1. I don't know if it's going to cross at 1. This dotted line I've drawn here, by the way, this dotted line is not a part of the graph. This dotted line is an asymptote. It is to do with the graph, but it is not the graph. So I need to find out this point where it intercepts here. How do I find out where it intercepts at this point? Y equals 0. So if y is equal to 0, we're going to solve that equation. 0 equals 2 over x plus 1. So I'm going to subtract 1. And then I think about it as these two swapping places. But you can either multiply by x and then divide by minus 1. And so x is equal to 2 divided by minus 1 or minus 2. So this point that we have here is minus 2. So let me just make this crystal clear. The graph that I have drawn in blue is y equals 2 over x plus 1. And the graph that I drew in grey is y equals 2 over x. And I've shifted it one space upwards. The asymptote that was previously the x-axis, or y equals 0, is now y equals 1. So this is the next one that we're going to try. I'll give you just a couple of seconds to finish doing that bit that you've got there. This is a really important part of the lesson, so well done for everyone concentrating really carefully here.
So will that one be like left and right?
Good. This one's going to be a left and right one. So I'm going to start off by saying let f of x equal the one that we know how to draw. And the one that we know how to draw is 2 over x. Then our one, y, is equal to f of x plus 1. Because this is telling you, instead of putting x inside the function, it is telling you to put x plus 1 instead of x. That's what this notation is telling you to do. Don't put x inside. Don't make those things be like that. It is saying put x plus 1. So it will be 2 over x plus 1. Notice how the x has become an x plus 1. The x is an x, the x plus 1 is an x plus 1. And so what I'm going to do here, this f of x plus 1 is a translation. How does it move? 1 to the left. Minus 1, 0. So I'm going to do the same thing as before. I'm going to start off by doing my grey sketch, which is going to be this graph that I have here. And we know that that looks like this. You don't always have to draw that. You could just go straight into the second one. But for this beginning bit, I want to move it to the left. And I'm going to do this graph now. I'll do it in a red colour to show you that it's different. This is going to move 1 to the left. Now, if it's moving 1 to the left, this asymptote that we have here is going to move to the left. So I'm going to draw an asymptote over here. And now I've got generally what the shape is going to look like. You don't need to look at the grey one because you now know it's just all shifting to the left. I'm just going to draw that shape. And I'm going to draw that shape that we've got there.
So does it touch the axis
No,
now?
it's going to touch this axis.
No, but
It won't touch this.
the top one.
Yeah?
So all the asymptote.
Oh, it looks like it's touching it. It shouldn't be touching it, no.
So all the asymptote equals x equals minus 1.
Good, yes. So the asymptote is that x is equal to minus 1, and the graph is y equals 2 over x plus 1. So try and ignore the grey one in the background. We use the grey one as a thinking tool to shift it to the left. But the answer is the red graph, just like the answer to this first one is the blue graph. So we're going to do the same thing for this one at the bottom for an idea of sketching. I've just done them with reciprocals. You may have to do it with other graphs as well. So what am I going to let f of x equal in this last one? 4 over x squared. Then that means that y is equal to f of x plus 3 inside the brackets or outside the brackets? Outside the brackets, because it's being added 3 afterwards. If it was inside the brackets, if it was f of x plus 3, it would be 4 over x plus 3 squared. Do you agree? That's what it would look like if it was inside the brackets. You make it change to the x thing. So what does this represent? A translation of 0 minus 3? 0, 3. It's going to move 3 spaces upwards. So I'm going to just think, it's not to the right, it's upwards. Because of what we said
Outside.
here. It's outside, so it's going to be 0, 3. It's going to move 3 upwards. So I'm going to start off by doing my graph. What does the 4 over x squared graph look like? No? What does 4 over x squared look like? Yep, like the praying hands, like the 2 bits that look like this. So it looks like this, and it looks like this. There's an asymptote along here, isn't there? So I'm now going to add 3 to it, and I'll do this one in a purple colour. So it's all going to be shifted up. So there's the asymptote, which is y equals 3, and it's just going to be that same pattern of the praying hands like that. So this graph that I've just drawn is y equals 4 over x squared plus 3. The whole thing has shifted up 3 spaces from where it was before. So the blue one and the purple one are both shifting up. The red one is shifting left. The reason that's happened is because this one was inside the brackets, which is the left and right. These ones, f of x had the plus 3 and the plus 1 that was outside the bracket, so it was shifting up and down.